Good morning, everyone. My name is Prisha Agrawal. I'm a student of Vellore Institute of Technology, Chennai, and I'm in second year with a course in CSC and specialization in data science.
Begin, let me ask you a simple question. When you send a message on WhatsApp or attend an online class, how does the information travel from your device to another device? Within seconds? Behind these everyday complexities, there lies a complex system known as the computer network. Although we do not see it directly, networking technology works continuously in the background to ensure fast, reliable, secure communication. Every click, message, or video stream depends on multiple devices working together through predefined communication rules. Understanding these concepts helps us appreciate the invisible infrastructure supporting modern life. In today's lecture, we will understand the fundamental concepts of computer networks, why networks are required, how devices are arranged using different network topologies, and how communication is governed using protocols and standards, which will form the advanced foundation for the networking topics that we will study later. What is a computer network? A computer network is a system that interconnects multiple autonomous computing devices to enable them to share data and resources efficiently. These devices include printers, laptops, computers, smartphones, servers, and other digital equipment, which is used in daily operations. The interconnection between devices can be achieved using wired media such as Ethernet cables or wireless technologies such as Wi Fi and mobile networks. Each device functions independently but becomes part of a larger system through network connectivity. This interconnected structure allows devices to exchange information quickly and accurately. It also enables centralized management of data and services. The Internet is the largest and most familiar example of a computer network connecting billions of devices across the world and enabling global communication, learning, and business activities. Why do we use networks? Computer networks are widely used because they enable effective sharing of resources among multiple users. Instead of having separate printers, storage devices, network allow these resources to be shared, reducing overall cost, improving efficiency. Networks also support enhanced communication through email, instant messaging, video conferencing, and social media platforms. These communication methods allow people to collaborate in real time, regardless of the location. In addition, networks play a crucial role in business and services by supporting cloud computing, online banking, e commerce, digital education, and healthcare systems. Organizations depend on networks for data storage, security, and service delivery. In today's digital era, networks are essential for both personal convenience and professional productivity. What is network topology? Okay, so network topology refers to the layout or arrangement of devices and the interconnections with a network. It shows how each device is known as a node, is connected to others, and how data flows through them during communication. Topology plays a major role in determining network performance, reliability, scalability, and maintaining performance. The maintenance cost. A well chosen topology improves efficiency and reduces network failures. There are two main aspects of topology: physical, okay, which describes the actual physical arrangement of cables, switches, and devices within the network, regardless of the physical layout. Logical topology explains how data moves within the network. Understanding topology helps network designers plan networks that meet specific requirements such as speed, reliability, communication, cost. So, we have different topologies. Each topology offers unique ways to connect devices with specific advantages and considerations. First, we have bus topology. So, in bus topology, all devices are connected through a single central cable called the backbone. When a device sends data, the signal travels along this backbone and reaches all the connected devices. Only the intended receiver processes this data while others ignore it. This topology is simple and inexpensive to implement, making it suitable for small networks with limited devices. It also requires less cabling compared to other topologies. However, bus topology has serious drawbacks because if the backbone cable fails, then the entire network collapses. It stops functioning. Network performance also decreases significantly as you add more and more devices, and identifying faults become as same as difficult. Because of these disadvantages, bus topology is rarely used in modern networking environments. Then we have star topology. In star topology, each device is connected to a central hub or a switch. All the communication between these devices passes through this central point of a hub, making network control and monitoring easier. One major advantage is fault isolation. If one cable device fails, for say, device 1 fails or device 2 fails, other devices will still work with proper functioning and the data will be passed. So, this increases overall reliability and it simplifies troubleshooting to a large extent. It also allows easy expansion, as new devices can be added without disrupting the older ones. However, the central hub or switch acts as a single point of failure. If this central hub fails, the entire network becomes non-functional. It doesn't matter if all the devices are working, but the data will just not be able to pass through. So, despite this drawback, star topology is the most commonly used one in the modern local area networks due to its flexibility and ease of maintenance. Then we have ring topology. In ring topology, devices are connected in a closed loop, forming a circular connection communication path. Data travels in one direction around the ring, passing through each device until it reaches the destination. This structured flow reduces the chances of data collisions and ensures predictable network performance. Each device plays an active role in forwarding data. However, ring topology has several disadvantages. A single break in the cable or failure of a device can disrupt the entire network. Troubleshooting such failures is also very difficult and time consuming. Additionally, adding or removing devices is complex and often requires temporarily shutting down the network. Due to these limitations, ring topology is less commonly used today. Then we have mesh topology. In mesh topology, each device is connected to other every device. This device 1 is connected to device 2, device 3, device 5, device 4, and device 6, vice versa. So every device is connected to every other device in the network. This ensures that data does not rely on a single route to reach its destination. If one connection fails, data can be rerouted through another available path. Because of this, mesh topology offers extremely high reliability and fault tolerance. It is particularly suitable for networks where uninterrupted communication is critical. Mesh topology also improves performance by allowing data to choose the most efficient route. However, this topology requires a large amount of cabling and hardware. Due to its complexity and cost, it is typically used only in critical or specialized applications. Now we have advantages and disadvantages of our four topologies. Each network topology has its own disadvantages and advantages, and no single topology is ideal for all situations. For example, bus topology is very cost effective and it is easy to install, but it suffers from low reliability and poor scalability. Star topology provides better performance, easy fault detection, and flexibility, but depends heavily on the central hub, which can be its own downfall. Ring topology offers orderly data transmission and predictable performance, but it lacks flexibility and it is highly sensitive to failures. Mesh topology provides excellent reliability, security, fault tolerance, but it is expensive and it is hard to implement. It also requires a large amount of hardware and extensive cabling. The selection of a topology depends on your network size, budget, performance requirements, reliability, and needs. Understanding these parameters helps us in designing efficient networks. Now, what are network protocols? Network protocols are a formal set of rules that govern how devices communicate within a network. They define how data is formatted, transmitted, received, and acknowledged during communication. Protocols also specify how errors are detected and corrected to ensure reliable data transfer. Without protocols, devices would not be able to understand each other even if physically connected. Protocols act as a common language that enables communication between devices from different manufacturers. They also manage data flow and ensure efficient use of network resource. Examples of commonly used network protocols include TCP/IP for internet communication. It is the foundation of the internet. It enables reliable data transfer. TCP stands for Transmission Control Protocol and IP stands for Internet Protocol. Then we have HTTP, Hypertext Transfer Protocol. It is used for accessing web pages and transferring data over the World Wide Web. Then we have FTP, which is the File Transfer Protocol. It facilitates the transfer of files between computers on a network. Now we have key elements of protocols. Every network protocol is defined by three key elements: syntax, semantics, and timing. Syntax specifies the structure and format of data messages, such as the order of bits and fields. It is like the grammar of the communication language. Then, semantics defines the meaning of interpretation of each section of a message. It ensures that both the sender and the receiver understand the purpose of the content of our transmitted data. Then we have timing. Timing addresses when and how rapidly data should be sent. It controls how fast it is transmitted, when it is sent, the sequence of communication basically. Okay, it also manages flow control and synchronization between devices, preventing data collisions and ensuring efficient delivery. These elements work together to prevent data loss, duplication, and delays. As a result, communication becomes accurate, efficient, and reliable. Now, what are network standards? Network standards are universally accepted specifications that ensure interoperability and compatibility between different devices, software, technologies, which is developed by various manufacturers. These standards are very crucial for building cohesive and functional global networks. Without these standards, each company would design its own communication methods, making global connectivity impossible. These standards ensure uniformity, reliability, and smooth integration of networking technologies. They also promote fair competition and innovation. They are developed and maintained by influential organizations committed to fostering open and integrated communication systems. Various key standard setting organizations are IEEE, which stands for Internet Institute of Electrical and Electronic Engineer. Okay, this is known for local area network standards like IEEE 802.34 Ethernet. This enables devices within our local area networks to communicate effectively. Then ISO standards, International Organization for Standardization, they provide conceptual frameworks like the OSI model, which has which is very crucial for communication. Then we have ITU, which is International Telecommunication Union. Its standards regulate global telecommunications as its major point. IETF is Internet Engineering Task Force. It is responsible for Internet standards, including the core protocols of TCP/IP, to ensure reliable Internet communication. Together, these standards make worldwide networking possible. To conclude, computer networks are essential for communication, data sharing, and modern digital services. They connect people, devices, and systems across the globe, facilitating information exchange and collaboration. Network topologies define how devices are arranged and how data flows within a network. Protocols and standards govern the rules of communication, ensuring reliable data exchange. Standards ensure compatibility and interoperable communication across diverse systems. A strong understanding of these concepts form the foundation for advanced networking concepts in the technology that power today's world. Thank you.